Okay guys, sorry about the video. It cut off. I don't know why, but again, I just had like a good 10 minutes of just talking to no one. Yeah, so let's do just this example that we were on. I have it already all worked out for you, so we'll just go through it. Again, you were given this molecular equation, so that is something that I was given, and it is already balanced, so you need to make sure, first of all, though, that it's balanced for you. If it's not balanced, then you're going to need to make sure to balance it. My next step was that I needed to dissociate things into their ions. So I went through HCl, I know that's hydrochloric acid, so I have to ask myself those rules. It's aqueous, but is it a soluble salt? Is it an ionic compound? Is it a strong base? Is it a strong acid? Okay, well, HCl, hydrochloric acid, that is one of our 7 strong acids, which means that we can dissociate it into its ions. So if I dissociate this into its ions, I get H plus Cl minus. But there are 2 HCl's, which means then that 2 distributes to the H and to the Cl. So that's why I have 2 H plus 2 Cl minus, because that 2 has to go to both of them. It's not just 2 H's, it's 2 H's and 2 Cl's. So 2H plus 2 Cl minus. Next step, FeS. I have iron 2 sulfide. It is a solid. Can I break apart that solid? I cannot, because it's a solid. Remember, my rule to dissociate only applies if it is an aqueous solution. Well, this is a solid, which means I can't touch that. So FeS, leave it alone. I brought it down, didn't dissociate. Next one, product side, H2S. I have hydrogen sulfide. It is a gas. Can I break apart a gas? You absolutely cannot break apart a gas, because again, it is not aqueous. It cannot dissociate into ions, so that means I can't break it apart. I just brought H2S down. Next one is iron 2 chloride. It is aqueous, so I have to ask myself, is it a strong acid? Is it a strong base? Is it a soluble salt, aka ionic compound? Well, it's not a strong acid, it's not a strong base, but it is a soluble ionic compound, or a soluble salt, because it's ionic compound, metal, nonmetal. It is soluble because it's aqueous, so I have to break that down into ions. So if I broke that down into ions, I'm going to get iron with a +2 charge, and then chloride ions, but there are 2 of them, so I have to write 2 Cl minus. Could I have written Cl2 minus like that? Oh my gosh, no, because that doesn't even exist. Cl2 we know is diatomic, that's a molecule, or it's one of my diatomic elements, and Cl2 does not exist in an ion form. So if I were to write the 2 down in the subscript, you're actually representing something that just doesn't even exist. So the AP chemistry graders would be like, ah ha ha, silly, silly mistake. So make sure that you bring those subscripts out in front as coefficients, because those are simply just telling us how many of those ions do we have present. So I never want to leave that there. I want to bring it out in the front. Okay, so 2 chloride ions. So now my next step is to cancel out spectators. I have 2H plus on the reactant side. Do I have that here on my product side? I do not. I have 2 Cl minus on my reactant side. Do I have the exact same thing on the product side? I do. So that means I can cross those out. Those are spectators. I have FeS. Do I have the exact same thing on the product side? I don't. So I'm done canceling out spectators. All I have left to do is write the net ionic equation, which is simply just writing what I have left over. So I have 2H plus FeS is going to produce H2S plus Fe2 plus. So that is my net ionic equation. Chloride ion is really just present and it's there, but it's not doing anything in the reaction itself. So net ionic equation, boom. What I would like us to do now, I want us to do some practice with writing our complete ionic equations and net ionic equations. So the rest of class time is going to be spent working on that. Tomorrow we're going to work on some more complicated examples of these ionic equations, because I want to look at some that are possibly weak acids, and then I also want to look at what happens to a strong acid, because there's kind of a little trick that goes along with those two. So we'll look at those tomorrow, and then we'll have more practice with them tomorrow, because the only way that we are going to be perfect at these is if we just practice, practice, practice. So today we'll do some more of these. Tomorrow we'll do even more of them, and then Friday you are going to have an acid and base lab. Your acid-base lab, we haven't yet got to those slides 20 through 34 that I wanted to go through, but we will go through them. So I may make that video and post it on Thursday, but now I'm thinking that I'll probably just make you watch it on Monday. I think we'll do that. So, yeah. So remember, for your lab on Friday, closed-toed shoes, I would prefer you, actually I'm just going to tell you, long pants. I want you to absolutely wear long pants for your lab on Friday, because your lab on Friday you're going to be working with some stronger acids. So closed-toed shoes, long pants. If you don't have those things on, or like a long dress or long skirt is fine. If you don't have those on, you sit out of the lab. I will see you guys on our next video. I hope you have a great day. I hope you're having an awesome homecoming week. Bye!